Great. Hello, welcome to today's webinar titled Climate Resiliency in Transportation Research. This webinar is part of Transport Canada's Transport webinar series, adapting to a changing climate webinar series. I did not do that properly. This webinar is part of Transport Canada's Adapting to a Changing Climate webinar series. Off to a great start. My name is Suzanne Sealing. I'm with the Climate Risk Institute, and I'll be the facilitator for today's webinar. I want to acknowledge that I'm speaking to you today from the Robinson-Huron Treaty Territory on the traditional lands of the Atikameksheng, Anishinaabeg, as well as Wenapatee First Nation. I invite you all to introduce yourselves in the chat box if you would like, and include your own land acknowledgement. I will be available during the webinar if you run into audio or technical issues. To ask me a question, open the chat box and use the drop-down arrow to locate Suzanne Sealing. Then you can send me a private message. Please note your microphones have been disabled to avoid any audio distractions or feedback during the webinar. There is a dedicated Q&A session at the end of the webinar, but that doesn't mean you have to hold your questions until then. Please feel free to type them out during the presentation in the Q&A box. The chat box is also available if you would like to submit comments. We are recording the webinar today and we'll be sending out a link to everyone who is registered along with a copy of the presentation slides. While today's webinar will be held in English, we will share a French version of the presentation slides. It is now my pleasure to introduce our speakers for today's webinar. We have Marla Dessat. Marla is a Technical Outreach Officer with the National Research Council of Canada. She delivers strategic and technical outreach and knowledge translation activities to support the efforts completed under the NRC's climate change adaptation initiatives. These initiatives will provide the knowledge to adapt public infrastructure, inform changes to building and infrastructure codes, and create guides, standards, tools, and technical solutions for climate resilience. Marla holds a Bachelor of Applied Science, Chemical Engineering from the University of Waterloo. She has a decade of experience working in the public sector on climate change and air pollution. We also have with us Isabella Jimenez. Isabella is a project manager and researcher with the National Research Council of Canada. Her work focuses on climate resiliency for rail passenger systems. It also extends to risk assessment projects for hydrogen and battery-powered locomotives, ensuring the safe implementation of zero-emission technologies. Isabella holds a bachelor's degree in mechanical engineering from the University of Ottawa and is committed to advancing initiatives that align with the goals of the Paris Agreement and bolster climate resilience in the rail sector. On behalf of everyone joining us, I'd like to warmly welcome Marla and Isabella for presenting this webinar for us today. We appreciate it. I will now hand things over to Marla.
Thank you so much, Suzanne. It's a real pleasure to be here today to speak to you about the work that we're doing at the National Research Council on climate resiliency for transportation. And first, I'm just going to give a little bit of background on who we are. So if we go to the next slide, the National Research Council, if you haven't heard of us, we are an agency of the Government of Canada. We have laboratories and research facilities all across the country, and the one in the picture here is our headquarters in Ottawa. The National Research Council has a range of activities that we offer, including technical and advisory services. We have collaborative research programs that we undertake, and numerous other opportunities for us to work together with industry, with governments, and with academia to increase access to research and development work and to advance that into the marketplace and into practice. We have 14 different research centers across Canada. And so we have research and development expertise in a wide range of areas, including aerospace engineering, biomanufacturing, construction, which is where I'm located in, and as well as automotive and surface transportation, which is where Isabella is from. And so that's what we'll be focusing on today. So moving on to the next slide, the work that we do at the National Research Council includes things like research initiatives, which is a group of projects all looking at the same topic area. And so the initiative that I support is called the Climate Resilient Built Environment Initiative. And my role as a technical outreach officer at the National Research Council supporting this initiative is to make sure that the work we do gets to the people who can use it. So it's my worst nightmare to have research results sit on a shelf and get dusty. So my role is to make sure that those results get connected to places where it can be integrated into policy, to places where it can be integrated into standards and other kinds of guidance and codes, and also into the hands of practitioners who can take those results and put it into their work. If you scan that little QR code up in the top corner there, it'll take you to our website that has all of the major outputs from this initiative and some previous work that we do. So moving on to our next slide here, we've been working on climate resilience at the NRC for quite a while. So we started with funding from Housing, Infrastructure and Communities Canada way back in 2016 with what we called the Climate Resilient Buildings and Core Public Infrastructure Initiative. So a bit of a mouthful, even the acronym CRBCPI is a bit of a big one. We slimmed it down for the current one. But that first set of work was 5 years of work on research looking at really everything that we build and how we can look at what the gaps are in terms of the knowledge and what's needed in order to then take that and put it into guidance, standards, codes, tools, other places where that research can then inform building in a more climate resilient way. So our current set of work, the Climate Resilient Built Environment Initiative, is running from 2021 through 2026. And so we're going to be talking to you about some work that's happening right now under that space. And we also had an expansion to our work through the National Adaptation Strategy. So in 2023, we received additional funding that will extend our work out until 2028. And that also expanded our scope to include residential retrofits for climate resilience. So prior to that work, we'd been quite focused on more the public infrastructure side of things, but have expanded to include residential buildings as well that are private. So I'm going to talk a little bit about the depth and breadth of what we're doing under this initiative. We have over 80 active projects. And if we go to the next slide, you'll see the wide range of hazards that we are considering in our research work. So we have ongoing research looking at the impacts of wildfire, looking at the impacts of permafrost thaw, looking at those short-term hazards like flooding and extreme heat and extreme wind, but also longer-term hazards that can damage the durability of our buildings and infrastructure. So things like corrosion and the impact that that can have over long term and how that's going to change with climate change in the future. We also have some brand new work that's looking at wildfire smoke and the impact that that has, especially on our most vulnerable populations, so places like long-term care facilities, and looking at how that can combine with some of these other hazards. So when you have a very high extreme heat event, but then you also have wildfire smoke, you have competing needs where you want to have more ventilation and bring in more outside air, but then that's bringing in that wildfire smoke and that particulate and all the challenges there. Along with all these hazards, we're also looking at nature-based solutions and nature-inspired solutions. So opportunities to use nature in order to reduce urban flooding, to reduce urban heat islanding effects in order to reduce the overall impacts when we do have extreme heat events, as well as looking at coastal flooding, coastal storm surge and erosion, and how nature-based solutions can be used to resolve that, as well as riverine flooding as well. So that's a lot of different hazards. We also have a wide number of assets that we look at. So going on to our next slide, when we first started this work back in 2016, we were really focused on public infrastructure asset types. So we launched looking at buildings, bridges, roads, water and wastewater systems, and rail transit. And that was the initial kind of start where we began this work looking at climate resilience of our built environment. And then we moved and added on to this. If we advance along here to add our couple more images here. So in 2021, when we started our latest 5-year program of work, we added dams as one major infrastructure type. And then just this past year, we added that suite of work on residential retrofit. So you can see that we're covering a huge range of different types of assets, a huge range of different types of hazards. And so today we'll be really digging in on the transportation sector and the work that we've done in that space. But if you're interested about any of these other areas that we work on, I'd be happy to hear from you and give you some more detail on what we've done. Moving along to our next slide, I did mention that we started in 2016, so we do have a lot of guidance documents, data, some standards, some other pieces that are available right now for you to check out and use. So there's that QR code again that'll take you to our website, and I'll drop a link as well in the chat for us to that in a little bit here. But if you visit that page that we host, we have a whole list of everything that's available that we've completed that are kind of major pieces from this work on climate resilience. And I'll give you a couple of examples of the kinds of things we've produced that are pictured on this page. So in the middle, on the top line there, we have the National Guide for Wildland-Urban Interface Fires. And so that is a national guidance document that we published a couple of years ago now. It started to be used, started to be picked up into informing checklists for Fire Smart and other pieces. And right now it's being developed into a national standard of Canada as well. So it's a collection of all the expertise and the current latest knowledge on how do those wildfires, when they move into our urban spaces and we have that wildland urban interface fire, how does that happen? What can we do to reduce our risks? What are the actions that we can take in order to adapt? Just beside that one, we have our brand new coastal guidance document. So this is on that nature-based solutions side of things. So it was just published a couple of months ago, summarizing a whole host of work that's been completed on computer modeling, on lab work, and also field work to look at how we can use nature-based solutions to reduce our risks of coastal erosion and flooding. A couple other ones along the bottom there are some standards, some other kinds of guidance documents, as well as the last one on the bottom there is a study of the impact that we would get from implementing that national guide on wildland urban interface fires. And so our assessment there found that if we put the practices in that into place across the country, for every dollar that we invest, we would save $4 in avoided losses. So lots of really interesting pieces there, a huge suite of work. There's also a lot of effort that's been done on data for design. So that Design Value Explorer pictured on the side there is a fantastic web tool hosted by the Pacific's Climate Impacts Consortium. And that was developed alongside ourselves and Environment and Climate Change Canada to look at how are the design variables that we use going to change for the design of buildings and bridges looking out into the future. And that's available right now to use if you want to go play with that and see what that looks like for a whole host of important climate design variables. So we've got a huge amount of work that's happened starting from 2016. That's just a quick sample of some of the things that we've done. And I'm delighted now to hand it over to Isabella to take you in depth on the work that we're doing in the transportation sector, both underneath the Climate Resilient Built Environment Initiative and also some other work that's happening independent of this push that we have. So handing it over to you, Isabella.
Thank you, Marilla. Okay, so as mentioned before, my name is Isabella Jimenez, and I am a research officer with the Automotive Surface Transportation Research Center. And I started working at NRC about 4 years ago, and right away started working on the project that Marla mentioned on transportation climate resiliency for railway transit agencies. And I'll give more detail on that. But before I start talking about all the amazing projects that we have, I wanted to give a quick overview of AST and the Automotive Surface Transportation Research Center here at the NRC. So as Marla mentioned, NRC is divided into various research centers, and us here at AST, we focus our research into two main areas. The first one is the material processing and manufacturing, and the second one is vehicle and transportation systems engineering. So AST Research Center is composed of several programs that focus on different aspects of transportation and manufacturing for road, off-road, and rail. And so there are two programs. The first one is the Clean and Energy Efficient Transportation Program, or CEET program, that supports the development of clean and energy efficient transportation technologies while striving towards a zero emission future. The second program, the Resilient Ground Transportation Program, or RGT. Its goal is really to enhance the efficiency, safety, and connectivity of Canada's transportation system, especially in the face of weather-related challenges. So it focuses on research, development, testing, and evaluation projects for freight, passenger, and off-road ground transportation sectors to deliver significant impact. And this program is divided into 4 thrusts. We have the Rail for Goods Transportation thrust, the Rail Passenger Transportation, Transportation Enabling Technologies, and Advanced Ground Vehicle Technologies. And all of the projects that I will be sharing with you today are part of this program and are under these thrusts. So now that I'm done with my little NRC pitch, why are we here? And let me go back to why we're here. The rail and road networks are the backbone for the Canadian economy, and it plays an extremely important role for the wellness of Canadians. And as we know, Canada is very wide. It has sparsely populated territories, and it experiences various extreme weather conditions. And this can make it very challenging to ensure the safe, secure, and efficient movement of goods and passengers in Canada. And so how do we ensure that such vast networks can face extreme climate events? So at NRC, our vision for resilient ground transportation is to go towards the path of data and technology-driven networks. So this can be done by making better use of existing data like past accidents, adopting emerging technology, using novel tools such as AI or machine learning, improving vehicle performance and resiliency by using onboard sensors or using digital twinning, and going towards a predictive risk identification approach. So I will be sharing with you 4 projects that are some of the examples of NRC's research that is geared towards this vision for both rail and road. So I am going to start with our rail-related research activities first. And when it comes to rail, railways have already implemented a lot of measures to have a more resilient system. So here at the NRC, we try to focus on 2 things to complement this work. So the first one is the enhancing rail network resiliency, where we're looking at targeting areas vulnerable to climate events to preemptive mitigation. And with this, we also want to develop tools to anticipate these events and be sure that we can prepare effectively. And in addition to this, we want to ensure that when these events do happen, we have a quick restoration of services after these events. The second focus we have is the adoption of emerging technologies. And I also have my first project that I will share falls under this focus. The second project I'm going to share on rail falls under the adoption of emerging technologies, where we can use things such as drones, AI, machine learning to enhance the monitoring and create a proactive responses when there's weather or climate events that happen. So I'm going to start with my project, the Guidance and Best Practice for Canadian Passenger Rail System project. And this is the project that falls under the initiative Climate Resilient Built Environment that Marla talked about earlier on. And just a little bit of background on this project. The idea of this project came from a discussion that we had with the transit agencies, the Canadian transit agencies, during one of our transit agency working group meetings. And these meetings, NRC has them every 2 months or so. And the goal of the working group, the transit agencies working group, is to give a space to transit agencies to share ideas and solutions to common challenges, to promote collaboration, and to identify opportunities for research projects. And so during one of these discussions and consultations with the transit agencies, they mentioned to us that they found that there was a gap in guidance tailored toward Canada's unique climate and conditions for the design, operation, and maintenance for passenger rail systems. And so we wanted to know why. Why do these gaps exist? What is the problem? And they mentioned 2 things to us. The first thing is Canadian infrastructure is aging. And in addition to the aging infrastructure, the stress that the infrastructure experiences by regular operation and extreme weather condition is not helping. And as we know, like we've said multiple times, Canada we can go from -40 to 40, or we can go, like, in the winter and the summer. And sometimes nowadays we can even go from -20 to 6 degrees overnight with the climates that we've been having. And so the climate change has even accelerated the stress that the Canadian infrastructure is experiencing. The second thing that they mentioned to us is that in Canada, we like to follow what our neighbor down the south does, the US. And most of the time, we end up using their standards, we end up using their best guidances, and we end up doing or working how they work and how they deal with things for their rail transit. And this, unfortunately, has brought some problems. And by the simple fact that Canada has a very different weather than the US, especially winter weather. And so a lot of the times, the US standards that we end up using do not take into account the amount of snow we get, the type of snow we get, or many of the other weather-related problems that we experience in Canada, by the simple fact that they don't have to think about it. So when we bring these standards and we end up using them, we start realizing and we start seeing we have this problem here that is not being addressed by the standards that come from the United States. And so with these two things that were mentioned to us, we started realizing that addressing these gaps and these challenges is very important for maintaining an efficient and resilient rail system here in Canada. So from this conversation, this project started in 2021, and the phase one was born of the project. And during our phase one, we wanted to know what these gaps were. We wanted to examine the current state of the climate-related research on Canadian passenger rail infrastructure. And we wanted to identify what were these challenges that the Canadian passenger rail industry was facing. And so to do this, we did three things. The first one is we did a small literature review to look at these codes, these standards, and these best practices that the transit agencies were looking at. But we also held an interview-based consultation with the Canadian passenger rail operators to be able to ask the question of, in your opinion, in your knowledge, in your experience, what are these gaps and what is missing for Canada to be able to be more climate resilient? So the third thing we did was also look at the climate and the weather here in Canada to have an idea of what we're dealing with. And we also wanted to see what weather events were affecting our infrastructure and our rail transit agencies. And so through the literature review and through our consultations with the transit agencies, we were able to find where the lack of guidance was, and we actually found a total of 10 gaps, and I'll talk about that in just a minute. But we also found that because Canada is so wide, and because your climate in Vancouver is very different than the climate, let's say here in the East, in Ottawa, Montreal, which is very different from the climate in Edmonton, the solutions for one might not be the same for the other. So that was something that we have to keep in mind for the next phase and for our research, was that we needed to think about Canada as a whole and all of our different type of climates, and not just one type of snow, one type of climate. When it came to asking about the weather condition, we have here a list of all the weather events that the transit agency mentioned to us affected their infrastructure and their transit agency. So we have very hot temperatures, very cold temperatures, fluctuation in seasonal temperatures. And I love that recently, I don't know where you are, but here in Montreal, a few days ago it was -20 and now it's literally pouring rain. So we kind of see it, how the fluctuation is very, very present. Excess precipitation, ice rain or freezing rain, snowfall, wind, and water level. So these are the weather events and climate events that were mentioned to us. And obviously, with the weather we have to think about climate change and how does climate change affect our climate and our weather. And we found, and I am sure this is no surprise for many of you, that we are going to have an increased number of hot days. There's going to be a decreased number of cold days, and there's going to be an increase in precipitation and a change in freeze-thaw cycle. And so with all of these weather events, we wanted to know which climate event affects what infrastructure asset for the transit agencies. And so we created this matrix to really just give us like a visual of what affects what, basically. And by doing this matrix, we realized that there's three things that really affect transit agencies, or I should say affect a lot of the infrastructure assets. And these three things, effect 4 to 5, are flooding, freezing rain, and snow. And I'll leave it at that because I'm going to talk a little bit further on this when I talk about phase 2. But this was something that was really interesting for us to find during phase 1. So now I'll talk a little bit about the gaps. I mentioned that we found 10 gaps, and obviously I don't have 10 gaps on the screen. This was just to give you kind of an idea of what we found. And I could talk about the gaps for the whole hour, really, and all the solutions we found for the gaps. But for this slide, I wanted to bring your attention to two gaps. The first one is the technology gap. So this was mentioned to us by the transit agencies, and obviously there were mentions of specific technologies that they would want to see or they thought we missed. But what I want to bring your attention to when it comes to technology gaps is the need for emerging technology and research in emerging technology. This can help by researching and testing technology here in Canada and testing it through a Canadian lens. This can really help our transit agencies use technology that we know is going to work for our type of weather and our type of climate. The second gap I wanted to bring your attention to was the knowledge gap. So there were three things that were mentioned to us that fall under the knowledge gap. The first one is transit agencies mentioned that there is a lack of quantitative research on climate effects on rail infrastructure. The second thing that they mentioned to us that there is a need for education and training opportunities for new hires. And every time I go to a conference or a presentation and we talk about transit agencies and their needs, this is something that comes up very, very often. The fact that they've had people that know how to deal with these weather events, but unfortunately, these people are starting to retire. And so the knowledge of how to deal with heavy snow and heavy winter weather is slowly leaving with the senior. And so when we're hiring new people, there isn't a way to educate them or a training for them so they're able to learn all these new skills and how to deal with this, with the effect of weather and the extreme weather conditions. And then the third thing that was brought to us through the knowledge, or that falls under the knowledge gap, is a lack of a document where we can see all of the solutions that know for these gaps and for the weather events that can work here in Canada and that are Canadian weather or Canadian based solutions. And so this brings me to our recommendations. Our first recommendation was obviously, let's form a committee, let's do something to address these gaps so we have solutions that know work here in Canada. Let me jump to the third one. Like I mentioned, enhance education and training opportunities in the rail industry. And my second point was to develop this Canadian specific guideline and best practice for climate adaptation. So when transit agencies know that snow is coming or there's heavy rain, they have a document where they're able to go and see what the solutions are or what they do to prepare for this type of weather. And this second bullet then brings us to our phase 2. So our phase 2 of this project, our main goal was to create this document. Let's do a document, a guidance and best practice document to help Canadian transit agencies be prepared for when extreme events happened. And so our main goal was, we already have the gaps, let's find the solutions. And to do this, we did a literature review on the solutions, and we did a survey and a little bit more interviews, but this time asking the transit agencies, what solutions have you tried that you know work for our type of weather? Another thing we started doing for phase 2 as well was we started looking at other countries, but not any country. We started looking at countries with very similar weather to us, which is mostly the Nordic countries in Europe, to be able to see what they were doing and what worked in their weather and see if we could bring those solutions here to Canada and see if they work for our weather as well. And so let me talk a little bit about the results we got from the interview and the survey. So the survey, we created an online questionnaire of around 26 questions. And obviously our first goal was to get the solution, document the solutions that were used for each of our gaps. But we also wanted to see from the weather events, which ones did the transit agencies think were affecting the most their infrastructure. And we wanted to see if this correlated to our matrix from the beginning, where we saw that it was flooding, heavy rain, and snow. So this survey was sent to Canadian transit agencies, and we received, I think, answers from most of them, if not all of them. And it was also sent to some international transit agencies, and I think we only got like 2 responses from international agencies. But what I wanted to share with you today was the result of the ranking of which weather events do the transit agencies think that affect the most their infrastructure. And no surprise, we see that heavy rains and flood damage and heavy snowfall and ice rain are the 2 weather or 3 weather events that affect the most the transit agencies. And just a caveat, we gave a scale from 1 to 5, 1 being, you know, this weather event is not really important, it doesn't really affect our transit agency, to 5, yes, it's really important, yes, we're having lots of problem every time that this happens. And as good human beings, we don't like to go to extremes. There wasn't a lot of 1 and there wasn't a lot of 5. So most of the answers all were between 2 and 4, but we still see, you know, a big difference between the other 3 to the heavy snowfall and the heavy rains. And another question we wanted to ask is, if we look at the weather events through different lenses, is the answer going to change? So if we're talking about how it affects operation versus how it affects the safety versus how it affects the economical side of it, or the reliability and service life of the railway infrastructure, do these answers change? And do the weather events change? And again, they don't really. Winter precipitation and flooding, so heavy rain, are the 2 that are usually, you know, the most concerning for transit agencies. After these 2, the following 2 would be the OCS corrosion and icing of power delivery. And one little thing about this is not all transit agencies in Canada have overhead cannery systems nor third rail. And so that's why they might be lower. It's not because they might not be important. It's just the fact that not all transit agencies have these systems. And so compared to, you know, they all struggle with winter precipitations because we have snow everywhere. They all receive heavy rain. So moving on to the literature review, and again, I could really spend a lot of time on everything we found, all the solutions we found through the literature review, but I am just going to stick to, you know, the most important parts. We looked obviously internationally, we looked at what other countries were doing. We looked at the ARIMA and the TCRP, which are the 2 documents that are the transit agencies here. These are 2 American documents, or North American documents. But we wanted to see what solutions were in there that actually worked and which ones didn't. And we were actually very fortunate to have found or have access to some Swedish documents that outline how Sweden deals with their very rough winter and with their winter condition. And this was really key to find some solutions that could work during our winter precipitation and our really harsh winter weather here in Canada. And we put those in our document to see, you know, these could be implemented in Canada and could potentially fill some of our gaps. So all of the information from the survey, the interviews, and the literature review was put into our technical document, the Guidance and Best Practice for Canadian Passenger Rail System. And this is a document that has been worked on for 3 years. And we're at a phase right now where the draft is completed, but we want to bring this information back to the transit agencies. And so we're working together with CSA to present this technical document during a workshop in end of March this year to get the transit agencies' feedback, to make sure that we have all of this, we have documented all of the solutions, to make sure that we're not missing anything. and to make sure that this is a document that the transit agencies are going to use, and it is a document that is going to help them. And more than that, we're really hopeful that this document can help feed information for future standards and future guideline documents that can be worked on for Canadians, by Canadians, through the Canadian lens, to make sure that our transit agencies are as climate resilient as possible. So the end of our project is March 2026, and that is when our technical document is going to be publicly available if you ever want to see it. So for this project, unfortunately, there were a lot of gaps, and we tried to fill as many gaps as we could, but there are some gaps that need a lot more research that we could have done in the past 3 years. We still have a year of this project, but there is a lot more work, a lot more research, a lot more testing that can be done to help the transit agencies make sure that they're climate resilient. And so through collaboration, rigorous testing, we need to make sure that there is an integration of climate considerations for rail design, maintenance, and operation. So that was for my project. Now let me move on to our second rail project. And I think this project is a rare representation of a tool that railroads, or emerging technology, I should say, that railroads and transit agencies could use to detect water accumulation near their tracks. And as I mentioned, flooding is a really, really big concern for transit agencies. So this is the integrating satellite and instrumented high rail truck data into current railway water inspection procedure project. And so this project has had various phases. It started in 2019, and during phase one, it was funded by Transport Canada Innovation Center. And phase one was really, the goal was really to evaluate the use of emerging technologies for water mapping. Phase two, also funded by Transport Canada Innovation Center, focused on conducting limited field trials in collaboration with VRL and McGill University, by combining data from 3 technologies or platforms into a single framework. And these were satellite, a drone, and a high rail truck. And while these trials were doing, it was found that this technology could also actually be used for more than just water mapping. It was found that it could also be used for vegetation and sideline monitoring. And so this brings us to our phase 3 of the project, which is funded by Transport Canada Rail Climate Change Adaptation Program. And the goal was to integrate these 3 technologies and this framework into a shoreline monitoring system. And I wanted to show some of the imaging that we get from these 3 types of technologies. So the first one is the satellite, and we have 2 types of satellite. The first one, the Sentinel-2, which is a 10-meter resolution satellite, and the Planet Super Dove, which is a 3-meter resolution satellite. And this can be used with your drone. So these are images from the drone. And when it comes to the drone, this imagery can actually help train algorithms that detect environmental changes affecting tracks. This can include water levels, water areas, and vegetation growth. And so this type of monitoring is really good for proactive network management. And it was mentioned in phase 1 that the use of drone and satellite technology could actually offer an inexpensive and effective method for detecting water near railway tracks under certain conditions. And the third technology, or emerging technology, but not least, is the high rail truck. This truck is owned by NRC, and as you can see, it has various sensors on it. We have a LiDAR sensor, an RGB camera, and an infrared camera. And so this is a equipped mobile platform with very diverse sensors used to create digital models of tracks and surroundings. So to the right here, you see the dashboard that's inside of the truck, and what you see in the image is what you see in the truck as you're moving the truck. And this information can then be used to create a 3D representation of the track and the environment surrounding it. So this can help see how far vegetation has grown, how much water is around the track as the truck is driving. So this is really a near real-time insight on track changes and the right-of-way for inspectors. This Another really good thing about this is you can keep this data as records, and you can compare it to newer data, and you can just see the changes of the track as you use the technology. So now moving on to road-related research activities. So the first thing I want to talk about was the Safe Truck Consortium. So NRC is part of the Safe Truck Consortium that has the goal to develop technologies focused on accidents involving heavy-duty vehicles and passengers in cold and winter weather conditions. So we are co-coordinators of the International Consortium project with the government of Finland through the Eureka Network Research. And so the reason for this consortium and this Safe Truck projects are that, as you see on the screen, 21% of the annual road fatalities in Canada involve a heavy commercial truck. And harsh weather is the primary contributor factor in 23% of all road accidents. And this is usually due to loss of control, jackknifing, and rollovers. So AAC researchers are developing advanced methods and technology to improve road safety in winter operation conditions. And this is specifically in particular with respect of multi-trailers, which is a Class 8 tractor pulling to 53-foot semi-trailers. And under this consortium, one of our projects is the development of electronically controlled active trailer steering systems. So the NRC is working closely with Canadian industry partners to create a prototype for an electronically controlled active trailer steering system. And this system is designed to enhance the performance of articulated heavy vehicles by considering road conditions, weather conditions, and vehicle dynamics. So basically, we're bringing together knowledge about how tires interact with the ground, how a vehicle behaves, and real-time weather updates to create a digital version or a digital twinning of the trucks and a system to predict road safety. And I have a few videos to show you. So these videos are about the effect of wind gusts on a truck. So as you can see, it's pretty impacting the video. And as you can see here, an average of 660 truck rollover incidents in Canada per year. And this incident can be compared to when using the active trailer differential braking system, what it could look like. So again, I think this is a great example of emerging technology and how it can help to make sure that our transportation is more climate resilient. So last but not least, I want to talk about our winter road project. And if you're like me and hear winter road and you think, isn't that every road we have here in Canada, but just in winter, you are wrong. In Canada, there's actually approximately 8,000 kilometers of official winter roads. And unlike roads that can be used all year round, which is what I thought, winter roads are seasonally constructed over frozen terrain or bodies of water like lakes and rivers. And we see an example right here, an image right here. So winter road systems are the lifeline of many northern and remote communities in Canada. So we think northern Saskatchewan, northern Manitoba. And they are built every year, allowing only for a short time window. It's usually between several weeks to a few months for the transportation of essential supplies to these communities. And these essential supplies could be food, fuel, medical supplies, construction material. But more than that, it also provides the community members access for social activities. It allows them to visit relatives and friends in neighboring communities or even accessing employment and healthcare. And when it comes to winter road, you need a specific number of cold days to make sure that the bodies of water freeze to a required depth or thickness to create a strong enough foundation for the safe passage of traffic. And as we mentioned before, there are more and more warm days with climate change. And so a warmer climate is reducing the operation window of these roads across northern Canada. And so much so that many segments of the current network may become less and less reliable. And therefore, we would need to replace these winter roads with other alternatives. And so there is a need to examine the winter road networks in Canada. There is a need to examine the factors that affect the safety of the winter roads. And there's a need to develop methods to review and quantify the impact of climate change across the winter road network. And so at NRC, we have created a framework or a system using public scientific methods, real world data from winter roads, and input from stakeholders and people who really know the roads well. And this system includes a dashboard, as we see right here, that does a few important things. First of all, it's going to look at weather data using the latest model. It is going to use past information like when the roads usually open and close to help figure out what the best timing for winter roads is and to check routes in detail. And it's also going to predict how the winter road season might go. So the system is going to help find any weak spots on the road network and is going to help decide which part of the winter roads needs attention first. And this is done by using solid information to make good decisions, especially when we're talking about climate change. So just a few conclusions with all the projects I've shared with you today. Extreme weather events can significantly impact the safety and operation efficiency of our transportation system. And this can impact Canadian economy and well-being of Canadians. So adopting and integrating emerging technologies in operation and decision-making can support the ongoing efforts to enhance the resiliency of our ground transportation system. So climate resilient transportation is about adapting and not avoiding climate impacts. And a continuation of collaboration between government organization and research institute, academia, and industry can enable technology development, testing, evaluation, and implementation. And before I am done and we go to questions, I just want to say I really, like Marla mentioned, I really just scratched the surface of all the work we do at AST on climate resiliency for transportation and at NRC as a whole on climate resiliency. This is a very important topic for us, and helping the transportation industry and giving them the tools to be climate resilient is always a goal for us and is very important. So with that being said, thank you very much. I don't.
Excellent. Thank you, Isabella and Marla. Excellent presentation. So we do have about 13 minutes or so to address any questions or comments that you may have. Please use the Q&A box to enter your questions. You also have the option to use the chat box as well if it's not working for you. We can get started here. It looks like we have a couple that have come in. So the first one, did you do a regional analysis of the average level of impact for various climate-related concerns?
I can speak to this a little bit kind of at the broader level. So generally when we are scoping our projects, we do try and look at the different issues that are going to impact regionally across Canada. And so one of the examples that I mentioned in my slides was that Design Value Explorer. And so that Design Value Explorer has those climate design variables that are used for the design of buildings, and that those are taken from the National Building Code. So looking at the data that's used in the National Building Code, as well as for the design of bridges, looking at the data that's used in the Canadian Highway Bridge Design Guide. And all of that data is based on specific locations in Canada. So there's over 600 different locations that have defined variables within the National Building Code. And so looking at that future-looking data, the work that we did with the Pacific Climate Impact Consortium and along with Environment and Climate Change Canada, that's all very regional and based on what's going to happen in those specific places. And then when you are designing a building or designing a bridge, you're looking for those particular impacts and that data in order to make sure that you're designing for the specific climate that you're worried about.
Yeah, I would have
Great.
to say the same for the transit agency. We're always looking at, like one example is the snow in Edmonton is very fluffy and you could really just, move it around with cold air versus the snow in Ottawa, who's very heavy, very wet, and cold air will not move the snow. So we're always looking at, Edmonton is obviously going to have a different solution than Ottawa.
Yeah, good point. Okay, next question. For infrastructure stakeholders, a key decision is the cost benefits of introducing climate adaptation measures. Is quantifying the impacts and cost part of the goal of the project?
So I can answer for me, it is not for this phase.
And I'll add on a little bit in general. We do some targeted studies to look at cost benefit analysis for the climate resilience work that we're doing. It can be of course, a challenging thing to assess when you're doing it in general. So when you're talking about a hypothetical possible application of solutions and looking across the whole country and looking at maybe a model or an example of how something might be done, doing that kind of hypothetical assessment of the costs avoided, or trying to price in the additional benefits that you get from choosing a solution in terms of other kind of co-benefits, either to the area or other pieces there, it quickly becomes a very complex economic task in order to assess those costs and benefits. And so there is often a tension between, do you do it at that general level or do you do it at the level of the individual project to evaluate what you're doing and the choices that you're making. In the ones that we have done, like the one I mentioned about the wildfire urban interface guide, we did find significant return on investment for every dollar put in to implement greater resilience to wildfire. And in many cases, some of those choices were a zero or very low cost change. So it can be, instead of a big change or a big investment, sometimes it can be just a change in the choice of a material or a change in the choice of a location for a selection there. So it's part of some of our projects to some extent, but we're not doing it kind of broadly for everything here. So we've got bits and pieces, but that's still a place where we'd love to have some more detail and some more work done.
Thanks. And then Amanda's asking if there's the report for phase 1 and 2 of the climate resiliency study for rail is available online.
It is not yet, but it will. The
Okay.
phase 2 will be in March 2026.
Okay. Great. Okay. Now's your chance to ask any questions for our presenters. We did receive a couple questions in the registration. So one question was, what do you see as the biggest challenge in bringing this research into practice?
Absolutely. So speaking kind of in general for the entire work on climate resilience, there is so many different places that we can integrate resilience into what we do. So it kind of becomes a question of where can't we bring this in and trying to find the best and the highest priority places to affect change and bring these new practices into what we do, because it can really be what we would call a horizontal or a cross society problem. So is it a change in the planning department at a municipality? Is it a change in how a construction company does its work? Is it a change in a regulation or another requirement? Is it all of those things? And then how do we push all that forward in order to make a change? So it can be a challenge, but also kind of a big, exciting opportunity in that there's a place in all of our work to look at what we're doing and say, can we do this in a way that's more resilient to climate change and extreme weather, and trying to all push forward together to make a more resilient space.
Mm.
Yeah, I would have to agree to that. It is a very, when we were doing the transit agent, when we started phase 1, you're talking about operation, maintenance, design, and you're like, where should we even start? Is it the design phase? Is it, we already have a lot of infrastructure that is done and we need to deal in, with what is going on already. So it is very big and it is a big opportunity there's just so much to be done.
Okay, thanks both. A follow-up to the study question being available publicly. This question says, even though the study won't be available until 2026, is it still possible to reach out to your team to get initial insights and a copy of this deck? I work on the High Speed Rail Initiative for Transport Canada.
Of course. Yes, you can reach out to me. I'm more than happy to talk about it. You're also more than welcome to come to the CSA workshop that we're doing at the end of March. I can forward the invitation for that.
We have another question from Jonathan. How are your studies on the impact of extreme weather events on transportation systems in Canada assess our current response to those disruptions to enhance resilience?
Can you repeat the question?
Yeah. So how are your studies on the impact of extreme weather events that affect transportation systems in Canada? How does it assess our current response to those disruptions? Or how does it essentially inform enhancing resilience? If I got that right, Jonathan, you're welcome to.
I'm not sure if I understand the question.
I think might be asking kind of to what extent has our current reactions to these kinds of extreme weather events been incorporated into the work that you did? And I think Isabella, probably through the interviews that you've done, you heard a lot about what's working and maybe what's not working
Oh,
right now.
yes, very much so. Yeah, I think also through our working group that we have, we always talk about it and we always make sure that we have, we know what is working, what isn't for the transit agencies. And when, let's say, a transit agency brings up a solution, we make sure that all the other transit agencies get the same information.
Super. We have another question actually as well. Do the guidance, documents, data, and standards for resilient construction in Canada include studies on the probability of climate events occurring?
I can speak to this one. So all the work that we do is really strongly informed by the work that's been done by Environment and Climate Change Canada and the climate scientists there to understand what those possible futures look like, what those scenarios look like, and also they're connected to the international community working on those as well. So we're at the NRC, we're generally not climate scientists, but we rely on our colleagues whose expertise is in that space to make sure that we're drawing on the best understanding that we have of those probabilities of various kinds of climatic events, and then looking at as well some of those different scenarios. So I know that for the work on buildings and on bridges, there's a lot of discussion, a lot of work to bring in the expertise on which scenario is the best fit to look at for the expected lifetime of that asset that we're looking at.
Great. Okay, we might have time for one more. It's a follow-up. So following up to the impact versus cost question, it was asked because it's a common question that's asked, and I'm aware of the existing NRC work on cost benefits for fire and wind, which are excellent. If there's opportunities to get involved and contribute to this effort, particularly from practitioners' perspectives, I'd love to know.
Absolutely. Well, thank you so much, Jack, for the compliment there on those pieces. Very glad to hear that those are considered excellent and useful. So that's great to hear. And absolutely, I'd be happy to get in touch with you and look for opportunities for you to connect with us. We are able to do a lot of work partnering with other folks in order to bring this stuff forward. So thanks very much.
And I did mention at the start, but I will be sending out a copy of the presentation deck as well as a link to the recording of this webinar at the end of the day today or sometime tomorrow. So keep an eye for that. Okay, thanks everyone. Okay, I'd like to thank everyone for joining us. We do hope you found this webinar informative, and thanks again to our presenters, Marla and Isabella. Also, a thanks to Arif Hussein at Transport Canada for helping to coordinate this event. Our next webinar is on Thursday, March 13th, It will feature a live demonstration of a suite of open access tools and support services that are now available through Housing and Infrastructure Canada's Climate Toolkit for Housing and Infrastructure. This toolkit is designed to assist infrastructure owners and decision makers develop projects that build resilience and contribute to Canada's path to net zero emissions. I have entered the link to find more information and register for that webinar in the chat box. Are there any final remarks from the presenters?
Just to say thank you so much for having us here today, and really encourage any of the attendees, if they'd like to reach out to us directly, we're always happy to hear from them.
Yes, thank you so much.
Excellent. Okay, thanks. Enjoy the rest of your day.